Okay, for what we have regarding matrix applications, one common type of economic model is the Leontief input-output model. And for what we have on display is a matrix D, which is referred to as the input-output matrix, where the columns will be in reference to the output and the row headings will be in reference to the supplier input. And for what we have with the Leontief model, okay, we have the designated matrix equation where X, which is the output matrix, is equal to D, again, the input-output matrix, times X, again, the output matrix, plus E. Now, E is going to be referred to as the external demand matrix. And some things about the inputs and the outputs. Okay, at the output, which is often referred to in economic modeling as the income, if we have it such that income exceeds the input, where the input is oftentimes the expenditures, then you're going to have the function to be productive. And if you don't have that particular surplus that is created, you're going to have the operation or the function itself to be non-productive. And just an application of what we have concerning the Leontief input-output model. Okay, we have with the service, electricity, and oil industries. And it says here that of the commodities produced by the service industry, you have 20% consumed by the service industry itself, 40% by the electricity industry, and 10% by the oil industry. And if you notice, okay, we have with the column totals, okay, you have we have service, you have 0.20, 0.40, 0.10, which will add up to 0.7. And we have thus that only 70% of services output is consumed by the economy. And service would be regarded as productive. Likewise, the description would apply to the oil industry, since in this case, the output from oil, we have 10 plus 20 plus 30, which is going to be 60%. And so we have both the service industry and the oil industry to be regarded as productive. On the other hand, electricity is completely consumed, where we have 50 plus 20 plus 30. Hundreds comes out to exactly 1. So you have all the electricity is consumed. So electricity would be regarded as non-productive. And we have, suppose that there is an external demand in the millions of dollars for 10, 10, and 30 respectively from the service, electricity, and oil industries. And the question posed is how much annual production will be required by the service, gas, and oil industries to meet both the internal and external demands for their commodities. Okay, so looking at what we have with the Leontief matrix equation, so you have again x is equal to dx plus e, and we got the d and the e established. Now for the output matrix we have with the variable terms, we'll say that x of 1 will be in reference to the service annual production, x of 2 for the electricity, and x of 3 for the oil. And so the output matrix is going to be a 3x1 array, okay, consisting of x of 1, x of 2, and x of 3. And looking at what we have for the matrix equation. So putting in the matrices in place of the variables. Okay, so you have for D, you have the 3x3 arrangement, and you have times the output matrix consisting of x of 1, x of 2, and x of 3. And we have plus the external demand matrix, where we have inside the figures in the tens, or I should say the millions of dollars, where we have 10, 10, and 30. And again, we have is equal to the output matrix itself. And following through on the operation, so you have x of 1 distributed over the first column in D, x of 2 distributed over the second column, x of 3 over the last column in D, and you have followed by the addition of the external demand matrix is equal to the output matrix itself. Okay, and so just looking at what we have, if I set up the respective equations, okay, and so we have from the first, okay, I have the equation set equal to x of 1. And if I join the x of 1 terms together and have the variable expression on the left, while simultaneously moving the constant in reference to the external demand over to the other side, and do the second equation in like fashion for x of 2 and moving the 10 over, and the last equation moving x of 3 and shifting the 30 over, I'm going to have this resulting system of equations. And just putting the external demand numbers in positive as opposed to negative format after having shifted. And so making everything that was negative into positives and vice versa. I'm going to have this adjusted system of equations. And I can arrange what I have here and put into a 3x4 matrix. So we have the first column being reference to the x1 coefficients, and second column will be for the x of 2 term coefficients, and then we had the third column we have in reference to the x of 3 coefficients, and again we have the last column with reference to the external demand numbers, and putting in reduced row echelon form. Okay, so we got for x of 1 that comes out to 61.74. Next row, okay, we have x of 2 is equal to 63.04, and for the last row we have what will be x of 3 is equal to 78.70. So the output matrix, again, is going to be a 3x1, where we have with the specified numbers. Again, we have x of 1 at 61.74, x of 2 at 63.04, and x of 3 at 78.70. So what that means for this particular situation is that for the service industry, it will need about $61.74 million annually. Electricity will need about $63.04 million annually. And for the oil industry, it will need about $78.70 million annually to meet both the internal and external demands.